Welcome to today's episode. I'm excited to dive into a fascinating new algorithm called DualPipe, introduced in the DeepSeek v3 technical report. This algorithm is particularly innovative because it represents a leap forward in how we think about bidirectional pipeline parallelism. So what exactly is DualPipe? Well, at its core, it aims to achieve full overlap between the forward and backward phases of computation and communication. Okay, I know that sounds a bit technical, but stick with me. Imagine riding a bicycle uphill. You don't just pedal at the same speed the entire time, right? You might slow down in some areas to gain speed in others. DualPipe is like optimizing that biking strategy to make the process as efficient as possible, reducing the times when you're kind of just hung up there, which we call pipeline bubbles. Now, the report mentions some schedules, and they use a really cool example with 8 pipeline ranks and 20 microbatches. These are basically smaller portions of a larger task that can be processed. The beauty of DualPipe is that these microbatches in the reverse direction are symmetric to those going forward, which helps in illustrating how tasks can overlap more effectively. Speaking of overlap, let's break down those pipeline bubbles. Ever been stuck in traffic? That's a bubble. DualPipe aims to minimize these slow spots. In a traditional setup, you might find bottlenecks where tasks are just sitting there. This can lead to inefficient memory use and processing delays. With DualPipe, the method reduces bubble parameters, allowing for a smoother and faster pipeline operation. Think of it as clearing the traffic jam so that more vehicles, like our data and tasks, can flow freely again. Now, if you're a developer and you're interested in implementing DualPipe, you'll want to be sure to use PyTorch 2.0 or above. This is really essential for real-world applications, as you'll need to tailor an overlap method specifically for your own modules. It's like customizing your bike setup to fit your riding style better. Before we wrap up, let's talk about the brilliant minds behind DualPipe: Jiaxi Li, Chengqi Deng, and Wenfeng Liang, who have contributed to this exciting development. Their work is pivotal, and if you want to dive deeper into their research, check out the citation in the show notes. To summarize, we explored how the DualPipe algorithm can enhance computational efficiency in machine learning via bidirectional pipeline parallelism, addressed the issue of pipeline bubbles, and highlighted its implementation within PyTorch. If you're a developer or a researcher, this is certainly an area to keep your eyes on. Thank you for tuning in today. I hope you found this discussion insightful. As always, I'd love to hear your thoughts or any questions you have on this topic. Until next time, keep exploring and innovating.